For each rectangle shown, draw a diagonal and estimate its length as accurately as you can. Assume each segment on the grid is 1 unit, and then describe any relationship that you see between the lengths of the sides and the lengths of its diagonal. So what I'm going to do in each one of these is I'm going to draw from the top left of the rectangle to the bottom right. I'm going to draw a line, and that's just the diagonal of this rectangle. So this diagonal, I want to see if I can find any relationships or maybe estimate its length compared to the rest of the triangle. Okay. So if I look at this, I see that maybe this diagonal, I can kind of see that it's going to be longer than the longest length of this triangle, or the longest leg, right? So if I take this and I just kind of let gravity make it fall, so it's going to start like this, and it's going to kind of fall down. So I'm just going to kind of trace a little arc. So maybe it falls to right about there. So to estimate the length of this diagonal, I just kind of let it fall. So I'm just going to count how many units it is across now. So we get 1, 2, 3, 4, 5, 6. So we get that the length of this diagonal is about 6 units. Okay. And we can do this for all of them, right? To get kind of a good guess on what this unit size is, or how many units a diagonal is. So if I let this one, I draw it, and I let it fall, so maybe it's falling this way now. Oh, not that. We kind of let it fall. Maybe it's going to land right about here, right? So maybe I'll just add 1. So I know that it's longer than this side, but we don't know maybe by how much. So I'm going to say 1, 2, 3, 4, 5, 6, 7, 8. So maybe it's 8 units when it falls. So this one's 8 units for this diagonal, right? So how many units would you guess that the bottom left one is? If we draw that diagonal. So how many units is the length of this diagonal?
7.
Yeah, so a good guess is 7, right? So we just count how many's on the bottom here and just add 1, because I know that it's going to be longer than either of the legs. Okay? And then we can do the same thing on the last one. Right? Just kind of let it fall. And maybe this one we're going to say maybe it drops 2 units. So maybe it goes right here. Right, so if I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So maybe this one's 11 units. Okay. So one thing that we can notice is that the diagonal is always longer than either of the 2 legs that encapsulates that triangle, right? So if we kind of look at this triangle, this diagonal is always going to be the longest side out of those 3 legs, right? And that's in the same thing in every one of these cases. So if we think about these triangles, we've just kind of been guessing on the length of the diagonals, right? So maybe what we can do is maybe we can kind of find something that will give us the exact length of the diagonal. Okay. So right now we're just estimating, but we need to find it more exactly. Okay. So the way we can do that is we introduce a formula. Okay. Okay. So does anyone have any questions before I go on to the next page? So we're not going to estimate these diagonals anymore. We're going to actually find the length exactly. Okay. Okay. So the Pythagorean theorem is the way that we can do this. So the Pythagorean theorem, it says a triangle that has one 90-degree angle known as a right triangle, or that has one 90-degree angle is known as a right triangle. So in a right triangle, the sides that form the right angle are known as the legs, and the side across from the right triangle is called the hypotenuse. Okay? So if I redraw this triangle down here, the right angle is the thing that looks like a 90-degree angle that has this little square down here. This is a right angle. Okay, so the legs are the 2 ones that touch that right angle, and the hypotenuse is the long side, which is across from the right angle. Okay, so the special relationship that we have is if we square the length of the legs, that's going to equal to the square of the hypotenuse. And I might post an announcement with kind of like a more intuitive thing as far as how you show that. But I'm going to leave it for now, and we'll just use this formula. Okay. So we have the square of the legs equals the square of the hypotenuse. Okay. So If we wanted to look at it, something maybe more familiar, so this is probably what you'll see in the textbook and just about everywhere else you look, is we have this formula. It's a squared plus b squared equals c squared. So that's usually what we refer to as the Pythagorean theorem. And this is known as a quadratic equation. So basically what a quadratic equation is your highest degree is 2. So your highest degree on an exponent, or your highest degree on the base, or the exponent is 2, right? So something squared. So if we want to look at something bigger, we would have, what, a to the third, and that would be to the third power, so that would be our degree, okay? Okay, so an example that we have for the length, let's see, so this one's, for example, in a right triangle whose legs have lengths of 3 centimeters and 4 centimeters, it says the hypotenuse is 5 centimeters, okay? So what I can do is I use this formula here, a squared plus b squared equals c squared. So a and b are the lengths of my legs, and the hypotenuse is c, okay? So I can say that 3 squared plus 4 squared equals 5 squared. Okay? So just to make sure that this is true, we can square everything, and then we can add them together, right? So we have 3 squared, which is 9, 4 squared, which is 16, and then that's equal to 5 squared, which is 25, right? And then 9 plus 16 is 25, so we get 25 equals 25, right? And that's definitely true, okay? So what I can say here is that this is a true statement. So this is a true triangle, right? So this actually exists, where we have the lengths of 3 centimeters and 4 centimeters, so the hypotenuse is 5 centimeters. Okay? And we won't always have that. We won't always be given all 3 of those. Maybe we'll only be given 2, so we kind of have to solve for them. Okay? All right. So let's move on to the next page, and let's look at some right triangles. So this example says, at John's school, there is a rectangular patch of grass called a quad that measures 350 feet by 520 feet. John needs to walk from one corner to the corner diagonally opposite him. He could walk along the sidewalks that line the perimeter, or he can cut across it in a straight line. So he says he knows that the shortest distance between 2 points is a straight line, but what will that distance be? And then how many feet will he save by cutting across? So let's look at the first scenario here, where he walks along the outer edge, okay? So if he walks along the outer edge starting here, so I'll just say that's A, and this will be B down here. Well, we know we have to walk this distance here, right? And then he walks this distance here. So how can I find the total amount of distance he walks if he does it that way, where he walks along the edge? So how can I find the total amount of distance that he crossed if he goes like maybe on a sidewalk on the outside edge?
So you're gonna do 350 squared plus 520 squared, right?
Not yet, right? So we're assuming that he's walking this, right? So he's going to walk this distance.
Are we
and then
just
he's
going to add them
this.
2 together?
Yep, you just add these 2 together, right?
Okay, so I just went an extra step.
Yeah, so you're on the next step. Yeah, so if we look at the distance that he goes from this right here.
870 feet.
Yep, 870 feet. And maybe I'll label that, I'll just label it a capital D for distance. Because we have a lowercase d, so we don't want to confuse that, right? So then if he walks this diagonal, how we can find that is we have this squared plus this squared is going to equal this squared. So we're just using that formula. So I can say that 350 squared plus 520 squared is going to equal the distance of the diagonal squared. Okay.
But since we already know that the distance is already 870, we can just square 870, couldn't we?
Not necessarily, right? Because this distance here is going to be different than the distance of this plus this, right? So that's why I have a capital D, because this is the distance that he walks from here to here and here to here, which is not going to be the same as this one here. I know this is going to be shorter because you don't have to walk all those extra steps, okay? So what we can do is we can square these both and add them together, right? So we have 350 squared, which is 122,500 plus 520 squared, which is 270,400. That's equal to our distance squared. So we'll add those two together. If we add those two together, we get 392,900. Okay, and that's equal to our distance squared. So how can we get the variable d by itself if we're squaring it?
Do we do the square root?
Mm-hmm. Absolutely. So the opposite of squaring something is square rooting. So we'll square root both sides. Right? So we get d by itself, and I'm going to move it to the left here. So we have d, and that's equal to the square root of whatever that is. So we get the distance is equal to, or the diagonal rather, is equal to 626 feet, I guess 0.81 feet. Okay, so we just square root that, we get 626.81 feet, right? So he actually walks a lot less distance if he walks the diagonal, rather than if he walks down here and then makes a right turn and moves over here, right? Okay. And then the last question says, how many feet will he save by cutting across? So how can I find how many feet he'll save if he walks across rather than walking on the outside?
Subtract the total distances.
Yep. Yeah. So you just subtract the distance if you walked around the outside by the distance of the diagonal. Yep. So we have 870 minus 626.81 feet. So if we do that, we get about 244 feet. So I'm rounding a little bit there. So we save about 244 feet if we walk the diagonal rather than if we walk around the outside edge. Yep. Okay.
So what did you do there? You just subtracted the 870 or the 820 and the 626.
Yeah, so I just subtracted
Okay.
the longer distance by the shorter distance.
I was just trying to figure out how to put it in my calculator, the square root, but I found it. So
Okay, gotcha.
thank you.
Yep. Okay, so as an extension to this problem, it says to determine how much time John will save, we need to know how fast he walks. Okay, so it says let's assume that he walks about 3 feet per second. Since it says distance equals rate times time, we can find the distance by dividing the rate by, or the distance by the rate. So that last part, it says we can find the time by dividing the distance by the rate. So we know the amount of distance that he saved is 244 feet, about, I rounded a little bit. So 244 feet. And I can divide that by my feet per second, which is 3. So 3 feet per second. Right? So we have our feet cancel and we're left with seconds. Right? So we just have seconds left over. So we just have 244 divided by 3. So divide that by 3. We see that he saves about 81 seconds after rounding. So he saves about 81 seconds walking this diagonal rather than walking around the outside edge. Okay. Okay. Anyone have any questions on this page? All right. Okay. So we'll do some more straightforward examples now. So this one says, find the length of a hypotenuse of a right triangle if the legs each measure 10 feet. Okay. So what I'm going to do is I'm going to draw a right triangle. Okay. And I know this is a right triangle, so I have to have a right angle there. I know that each of my legs measures 10 feet, so I have 10 here and 10 here. And I want to know the length of my hypotenuse, which I'll label h. So my hypotenuse is always just my longest side, which is always across from the right angle. Okay. So how can I find the answer to this question? How can I set up?
It would be 10 squared plus 10 squared.
Yep, 10 squared plus 10 squared. And what does that equal?
So it would be 100 plus 100 equals 200 feet.
Yep,
right?
so that equals 200, right? But what is that going to be equal to? Because I have to solve for something, right? I need a variable.
Oh, that'd be C equals C or
Yep,
the
c squared,
hypotenuse
right?
or H or whatever. Yeah.
Yep, h squared. Yep, absolutely. So on the left, we get 200. So 100 plus 100 is 200. And then let me rewrite that. So 200 equals h squared, right? And then just to solve for h, what we can do is just square root both sides again. Yep. So we'll just get h on the left. And on the right, we get the square root of 200, which is about 14.14. Okay. And that'll be labeled in feet. Okay. So the hypotenuse here is 14.14 feet. Right? So if we kind of did what we did on the first page where we kind of let it fall down, I know that we have like an extra 4 feet when it drops. Yep. Okay. So B says find the length of the legs of a right triangle. If the legs are the same length, then the hypotenuse measures 10 feet. So what I'm going to do again is I'm going to draw a right triangle. Okay. I know the hypotenuse measures 10 feet, right? So I know that. But I don't know what the legs are, right? So we have two unknowns. We don't know what this one is, and we don't know what this one is, right? So what if I label this one A? So this length of this side is A. And what can I label the bottom one? Maybe I'll just label it B for now. Okay. So if I wanted to set up an equation for this, I can set it up where I can have A squared plus B squared equals 10 squared, right? So just using that theorem. So A squared plus B squared equals 10 squared. Okay. But I know something else about the legs of the triangle, right? What do I know about the legs of this triangle here?
They're
They're the
square.
same legs.
They're the exact same length, right?
Oh.
So I know that A, the variable A, is the exact same thing as the variable B, right? So maybe I can just say that B is going to be equal to A, right? Because they're the exact same thing. So what I can do, instead of saying B squared, I can say that's another A squared, right? So I can have A squared plus A squared equals 10 squared, right? And the reason I'm doing that is because now I only have one variable, so I can solve for that variable, right? If we have two of them, we can't necessarily do that. But I have A squared plus A squared equals 10 squared, right? So how can I simplify this problem? So what's one step I could take to simplify this problem?
You
Make
can
it
just
A4.
A to the fourth, right?
So that's only if I'm multiplying, right? I add the bases.
Oh,
But this one, I'm adding one apple to another apple, right? So I have
So could you do
two.
2A squared?
Yep, so I have 2A squared, and then 10 squared is 100, right? So that's equal to 100. Okay. So how
Now you're
can I?
gonna divide two. You're gonna divide
Mhm.
2 on each side
Yep,
to get the
divide
A
it.
by itself.
Yep, so I have A squared equals 50. And now what can I do? So I have A squared, right? So the inverse to squaring is square root.
Square root,
Yep.
right?
So I have the square root of A squared is just A. And that's equal to the square root of 50. And the square root of 50 is 7.
7.07.
Yep, absolutely, 7.07. So I know that the lengths of my legs here, so A and B, are both 7.07. Okay, so we have a special type of right triangle. So we call these Pythagorean triples. And what they are, it's just when we have three whole numbers that satisfy the Pythagorean theorem, or the equation A squared plus B squared equals C squared. So we look at it, and basically what we're saying is that we have whole numbers for A, B, and C that satisfy this equation. And one example that we've seen from earlier is the 3, 4, 5 triangle. So that's usually the most common one. Is 3 squared plus 4 squared equals 5 squared. I think we saw it on an earlier page when we did an example as well. So if I use the Pythagorean theorem to complete each of the following triples, we get a 3, 4, 5 triangle. And which one is the hypotenuse here? Is it 3, 4, or 5?
5.
Yep, and why is it 5?
Because it seems to be following the order of A, B, C.
Okay. Well, what if I had 3, 5, 4? What would my hypotenuse be there?
Oh, I'm sorry. 5 is the hypotenuse because it's longer than the sides.
Yep, absolutely. So my hypotenuse is always my longest side, right? So it's going to always be the biggest number. Yep, absolutely. So the hypotenuse is always the longest side.
I don't understand what we're doing here.
So as far as you don't understand the formula, or you don't understand
Yeah, I don't understand what we're doing with these triples.
so these yeah, so these triples are nice because they're all whole numbers, right? So like on these ones above, we didn't work with whole numbers, right? When we
Okay.
get A, we get some decimal. So these ones are really nice because we get exact answers. We don't have to round. Like this 7.07 was actually rounded, right? It was 7.0710, so on. Yep. So these are rounded, but these ones we get exact answers. Okay. So that's the importance of these, is we get these exact answers.
But these are supposed to be the right triangles again, right?
Yeah, yeah. So this, if I wanted to visualize this 3, 4, 5, oops, I could draw a right triangle, something like that. And I know that the length of this bottom one is 4. The length of this leg is 3, right? And these could be interchanged. It doesn't matter. But I know that my hypotenuse is always 5, right? So these ones solve the equation, or are a solution to the equation of 3 squared plus 4 squared equals 5 squared, right? So they're a solution to the Pythagorean theorem. They're a whole number solution specifically. Okay. Does that kind of answer your question a little bit more, hopefully?
Or yeah, I
Okay.
think so.
Yeah. Okay. So what do you notice about going from this one to this one down here? So to the second one. So maybe we kind of go back to our pattern. So what do you notice as a pattern going from this
It
first
goes
one
by
to the second?
2.
Yep, you just multiply by 2, right? So if I follow that pattern,
Right.
what would the length of my hypotenuse be? So what would the length of my hypotenuse be?
10.
Yep, 10. Yep, absolutely. So what we've noticed now is if we have this triangle, we can just scale up each side by 2. So we can have a bigger triangle here. And we can have a side of 6, a side of 8, and a side of 10. And we still have the exact same solution, right? So what we've noticed is that we can multiply each side by some scale factor. So maybe 2, maybe 3, maybe 10, something like that. And we're still going to get another Pythagorean triple. Okay. So maybe we see that the first one compared to the third one, all we're doing is just multiplying by 3 each time. Right? So we get 5 times 3, we get 15. And then if we go from 3, 4, 5 to maybe 30, 40, 50,
50.
that's another solution. Yep. And then I'm going to skip the next one just for a second. And then if we scale from 3, 4, 5 to 60, 40, or 60, 80, we should get 100, right? So we're multiplying by 20 there. Okay. But I don't see an easy way to get from 3 to a 5, 7, 6 here. So this one is maybe another unique triangle, right? So it's maybe not a multiple of these ones over here. So how can I solve for this length of this hypotenuse that we don't know? So how can I solve for the unknown there? Well, I can draw a triangle, right? So draw a right triangle. And I know the length of one leg is 57. The length of another leg is 76, but I don't know the length of my hypotenuse, right? So how can I find the length of my hypotenuse here?
57 squared by 76 squared.
Yep, 57 squared plus 76 squared equals h squared. Yep. So I add those two together. So 57 squared plus 76 squared and I get 12,274, and that's equal to h squared. And then I just square root both sides. So we get h equals the square root of that number. And here we're getting, that's not good, we're getting,
110.78.
yeah, so maybe, did I mess up somewhere? Because that's what I got as well. I will have to go back and look at my notes because that should be a whole number there, but I'm not sure exactly what it's supposed to be. So I'll cross that one out for now. So that's an error in the notes. But I guess I'll give you another example. I know that one of them is 5, 12, 13. That's another example of a triple. You might see that come up in your homework. So it's probably good to write it down. So a 5, 12, 13 is also a whole number or a Pythagorean triple. Okay.
But it doesn't follow the rules of what we were just doing.
Right.
Like-
So it's not in the same ratio of this 3, 4, 5 triangle. So there's more triangles out there. There's actually an infinite number of triangles that are Pythagorean triples. So these are just like the smallest ones, the easiest ones to find. Okay. Okay. Any questions on the Pythagorean triples?
So what we're actually doing is if I would take, back to the first one, if I would take 3 squared and plus 4 squared, I get like 25, and then I do the square root, I get 5. So that's what we're actually doing with these 3 things.
Yeah, absolutely. So we're finding
Oh,
whole
okay.
number
Gotcha.
solutions to
Okay,
this
okay.
equation right here. Yep.
I think I understand now.
Yep,
Thank
absolutely.
you.
All right. Any other questions on this section? Oh wait, we have one. We have more. Just kidding. Sorry. Okay. So this one says a home builder is trying to. Oh, this is the last one. So it says a home builder is trying to square the corners of a property. So it says a string is secured 7 inches out from the corner of one side and 2 feet out from the corner of the other side. So as shown in the diagram. Okay. So it says one side is angled until 2 marks are exactly 25 inches apart, and then a stake is planted in the property corner for each mark. So it says, why do these measurements guarantee a square corner? And what are some other measurements that the builder could use that might be more convenient? So why does this guarantee a square corner? Anybody know? So why is this corner here square? So maybe what is a way that I could verify that these corners are square or this corner is square? Well, hopefully we'll use the Pythagorean theorem, right? So this a squared plus b squared equals c squared only works when we have a right angle, right? So if we get a true statement here, that'll guarantee that this is a right angle, right? So what is my a and my b in this case?
7 squared plus 2 squared.
So we have 7 squared, I agree with that, but I don't agree with the 2 squared, right? So does anybody know, why don't I agree with the 2 squared?
It's 7 inches.
Right, so we deal with inches here.
Oh.
Well, if we deal with inches here, we have to deal with inches here, right?
Okay.
So what is 2 feet in inches?
24.
Yep, so we get 24 squared, right? So we have 7 squared plus 24 squared, and we're going to say that's equal to 25 squared, right? So if the left side is equal to the right side, then we're guaranteed this right angle, okay? So because this Pythagorean theorem only works for right triangles. So if they aren't equal on the left and the right, this is not a right triangle, okay? Okay, so if I do that, we should get that answer though. So 7 squared plus 24 squared, we get 625 on the left, and 5 squared is 625.
Okay.
Yep. So we're guaranteed a right angle because we have 3 numbers that satisfy the Pythagorean theorem. Okay. And if you want to add to your notes, this is another example of a Pythagorean triple, right? Because we're given 3 whole numbers, and it's a solution to this. So 7, 24, and 25 are solutions to the Pythagorean triple as well.